We'll finish our discussion of equations and inequalities with the absolute value. What is this? Well, one way to think of it is just it's a number where I remove the negative sign if there is one. Another way to think of it is it's the distance of a number from 0. I think the second way is better to think of it this way. It generalizes more to when you don't just have single numbers but vectors, for example. So if you have an interest in math, science, computer science, it's more helpful to think of absolute value as distance from 0. Now, let's look at the formal definition. I have here that the absolute value of x is equal to x if x is greater than or equal to 0. So this is the case where there's no negative sign. And in the case where there is a negative sign, when x is less than 0, we drop the negative sign. Right? So the idea is that if I have a negative number and I hit it with another negative sign, it goes back to being positive. So just a simple way to write out the definition of this. So let's look at a plot here. So here I've plotted the function y equals absolute value of x. So at x equals 0, y is equal to 0. And then on this half of the graph, nothing happens. This just looks like y equals x here. But for negative values of x, the picture flips, and it becomes the function y equals negative x. So I get, on this side, the plot is y equals minus x. And this is totally consistent with our definition of, for positive values, do nothing. For negative values, add a negative sign so that the negative sign drops out. So let's just look at transformations of this. If I say had 2 absolute value x minus 3, what does this do? Well, again, we'll see that in general, adding or subtracting this number at the end just shifts the graph up or down. So here it's minus 3, so it shifts down by 3. So I have the value 0, negative 3. And then what does the 2 do? Well, it just changes the slope of the lines for this absolute value plot. The v that was having lines of slope 1 now sharpens and becomes slope 2. So here this is like slope positive 2, and over here the slope is like negative 2. So that's what the 2 multiplier there does, is it tightens the plot. It makes it more narrow. If I had a coefficient out front that was like 1/2, it would make it wider and more flat. So what kinds of equations might we be asked to solve? Well, something like absolute value f of x equals g of x, which can in general be tricky. But all I have to do is think about what does the absolute value do? Well, in the case that f of x was positive, it does nothing. So here, f of x is greater than or equal to 0. But if f of x is negative, I have to put a negative sign on here. So in this case, f of x is less than or equal to 0. So if I just remember the definition of the absolute value, I can always go with that. Now, this becomes particularly simple when I have a linear equation. In that case, the minus sign just distributes through the ax plus b, if there is one. So if I'm given absolute value ax plus b equals c, then all I need is that ax plus b is equal to c, or negative ax plus b is equal to c. So let's look at an example. If I have absolute value 2x minus 5 equals 1, then all I need is that either 2x minus 5 is equal to 1, or negative 2x, negative around the whole thing, equals 1. So this tells me that 2x equals 6, so that x is equal to 3. Or, here I have negative 2x plus 5 equals 1, so that negative 2x equals negative 4, which tells me x is equal to 2. So I check this. If I plug in 3 into the left-hand side, I get absolute value 6 minus 5, so 1. If I plug in 2, I get absolute value 4 minus 5, so absolute value of negative 1, which is also 1. Okay, so we can try to sketch a picture here. see what's going on. So if I plug in x equals, so I'll plot y equals absolute value 2x minus 5. So when x is equal to 0, y is equal to 5. So that's 1 point on there. When x is equal to 1, I get 3. When x is equal to 2, I get 1. When x is equal to 3, I've already seen I also get 1. So the picture is something like this in this case. So when I'm looking for when it's equal to 1, I'm basically drawing a line through the value y equals 1 and looking for the intersections, which I correctly computed to be 2 and 3. So again, I'm a big fan of trying to draw pictures when you can. Even if it takes some time on the CLEP exam, it can really help you check if what you're doing makes sense. So let's just look at one more. Let's look at absolute value inequalities. Again, what does this look like? Well, in general, it'll look like absolute value f of x is less than or equal to some other function g of x. And we can parse this or try to understand this by just remembering what the absolute value function does. If f of x is positive, it does nothing. If f of x is negative, it drops the negative sign by putting a negative sign in front of f of x. Remember, the whole idea of that definition is that the negative of a negative is positive. Okay? And that's all this says. Now, in the special case of having linear inequalities with absolute value, I can solve this in a very simple way by doing what's called the number line method, where I pretend I was solving the just equation by itself. And then looking in the regions that these solutions give me on the number line. So I plot the two solutions, in general there'll be two, solutions on this number line, and then I check a point in each region and see if it satisfies the inequality or not. And that tells me my solution set. So let's look at an example. So here I have absolute value x plus 2 is less than or equal to 5. Okay? So how would this work? I would start by solving x plus 2 equals 5. So x plus 2 equals 5, or minus x plus 2 equals 5. So x equals 3 is a solution. And x equals minus 7 is a solution. And then I do the number line. So I plot minus 7, and I plot 3. And then I pick a point that's representative from each of them. So for example, from the interval minus infinity to 7, or to minus 7, let's pick like minus 10. So I'll plug in minus 10 into my inequality. So absolute value of minus 10 plus 2, so 8. Is 8 less than or equal to 5? No. So I have a non-solution in this interval. Let's check the middle interval, minus 7 to 3. What's the simplest number I can pick there? How about x equals 0? Which is very convenient to work with. It's the only reason I pick it. There's nothing special about it. Then I plug it in. Absolute value of 0 plus 2. So 2. Is that less than or equal to 5? Is 2 less than or equal to 5? Yes. So this is a region of success. Everything in that interval will be a solution. And lastly, we'll check the outer interval on the right. So we'll look at absolute x being greater than 3. So let's pick a number like 10. Plug in 10. get absolute value of 12, which is 12. Is 12 less than or equal to 5? No. So that's a non-solution. So this tells me that my solution set is minus 7, x is greater than or equal to that, and less than or equal to 3. So remark, I include the endpoints. I include minus 7 and 3 because I don't have strict inequality. If I didn't have that equals sign there, negative 7 and 3 would not be solutions, because that would be when the left-hand side was 0, which would not be included in the solution set in that case.